Okay, so this is we have a pulley, which is a disc. So this is a disc. They have to specify what kind of pulley it is because each pulley has different inertia, the I. So if we tell you that this is a disc, the inertia is going to be 1/2 times mr squared. All right? And then the question is to find linear acceleration and angular acceleration. Now, these are the problems that I want you to understand perfectly. All right? Newton's second law in rotational motion. It's like the first one we did. All right. So what is A, what is alpha? Again, we're going to come up with maybe, well, let's put the forces in. The first one is the weight of the 25 kilograms. And then we have 4 kilograms here. So the first, you need to know which direction is the block is gonna go. Well, obviously 25 kilograms is more than 4 kilograms, so it's gonna go down this way, right? So we know we're gonna call this positive. Going down is positive. All right. So what equations can we write? Well, we have the weight here, which is 25 times 9.8. All right, and then you're gonna get 245 newtons. All right, no big deal. 9.8 times 25. Some of you don't even put that in. All right, and now we have tension, but now we're gonna have two tensions because we have two ropes. If we have two ropes, then we have two tensions. We call them T1 and T2. So this is T1, and this is T1, same tension. The one that's going from the box, and then you have another one which is the same thing, it's the same tension. And then we have another one which is T2, and then T2. All right? All right, so let's put the equations that we need. Well, first of all, is the Newton's second law to the box, to the 25 kilograms. So how would you write? What's the Newton's second law if you want to write it to the 25 kilograms? The weight, the mg for 25 kilograms, or the Newton's second law, how do you write it?
245 minus T1 equals 25.
All right, good job. 245 minus T1 equals to 25A. Box it. Every time you come up with an equation, box it because you're going to use it. All right, what else? Now we're going to do the torques. So how many torques we have?
Two.
We have two. One going with the T1, that's a force. And then the other one is T2, that's another force from the other rope. All right? So because we say that going down is positive, so that means this is going to go clockwise, right? If this comes down, that means the pulley is going to turn around clockwise. So you write clockwise. You write T1 times R. Remember, to find the torque in a pulley is the force T1 times the radius. That's the torque. The torque is what drives the pulley to turn around, to rotate. All right, so 1.5 T1, 1.5 T1, the radius is 1.5 T1, minus, because the other one is going counterclockwise. So the other one is going to have minus 1.5 T2. And then the whole thing should be equal to I alpha, because now it's moving, so we're not going to put it equal 0. It's not in equilibrium. So you're going to write it times equals to I alpha. All right? Now, we're going to calculate that, which is 1/2 times m, which is 10 times r squared, 1.5 squared. All right? And I'm going to save some time and just get the answer. So when you multiply that, 1.5 squared, and then you multiply it, you get the I equals to 11.25. And then you just plug it in here. All right, so you have 1.5 T1 minus 1.5 T2 equals, now we know what I is, 11.25 times alpha. Don't forget the alpha. So you have, it's easy to forget stuff because there's a lot of variables. So you're gonna be careful, all right? So we have, let's see what we have. We have T1, A, T1, T2, and alpha. All right? There is another equation that you can get from the system. What equation is that?
T2 equals 39.29. For the other box.
The other box, right. So we're gonna write T2, and we know it's going this way. This way is positive. So T2 equals just M, which is 4. Actually, this is 4 kilograms, sorry. That's 4 kilograms. All right. So T2 is going to be 4 times A. So that's another equation that's going to help us. So we have 1, 2, 3, and there is a fourth equation. What is that? What's the fourth equation? That always helps. To go from alpha to A or A to alpha.
A equals alpha times radius.
Exactly. A equals alpha times the radius. You have to memorize. That's why it's easier if you memorize some of the formulas, because it pops up in your head every time you need something. It just, like, instead of going and looking up for the formula, it just pops up and it makes the problem easier. All right. So you need to memorize some of the formulas. So we can convert that. We can change alpha to A, all right? Because we have A, T1, and T2 if we have alpha in terms of A, all right? And then we'll be able to solve it. We're gonna have like 3 equations, 3 variables. All right, let's change alpha in this equation here. In this equation, we change alpha. So I'm gonna get the alpha from here. So alpha is equal to A divided by 1.5. All right. If you divide by R is 1.5. So alpha is A over 1.5. So it's gonna be 0.666678. 0.66678. That's the alpha. If you divide, because this is like 1 over 1.5. All right, and then you just plug in that alpha in this equation here. So let's do that. I'm gonna erase this stuff here that I don't need anymore. I'm telling you, a lot of this stuff is algebra. All right, so I'm gonna go to this equation here. I'm gonna replace alpha by 0.6678. So 1.5 T1 minus 1.5 T2 equals 11.25 times alpha, but then alpha now we're going to replace it by 0.6678. So we won't have alpha anymore in these equations. We're only going to have T1, T2, and A, but then it's going to be 3 equations, so we should be able to solve it. All right, so equals to 11.25, and then multiply that by this. You're gonna replace alpha by 0.6678. All right. So let me just do it over here because I have a space. 1.5 T1 minus 1.5 T2 equals 11.25 times 0.6667 and then 8. All right. So I just multiply 11.25 by 0.667a. So it's going to have 1.5 T1 minus 1.5 T2 is equal, and then we're going to multiply 11.25 times 0.667. So I get, when I do that, I get 7.58. 7.58. And then I'm gonna box this. I'm gonna box that. So which equations I'm gonna use now? That have T1, T2, and A. So I have one. I can plug in T2, all right? And then, so let me go over here and then finish up the work. So I have the expression T2 in terms of A, right? So now I'm gonna bring this equation, and then I'm gonna replace the T2 by that, and then replace T1 from here. I don't know if you're understanding the algebra, all right? I have this equation in terms of A, T1, T2. I'm gonna bring that T2, put it in here, and then I'm gonna bring the T1 from here, put it in here. So I'm gonna have everything in terms of A. I'm telling you, what I'm teaching now is algebra. It's not even physics. All right? I'm gonna combine this equation, all right? And then this equation, the one that has stars. Again, I'm gonna take this T2, it has 4A, put it in the T2. And I'm gonna get the T1 from here, and I'm gonna express it in terms of A. So I'm gonna have that equation that has only A, and that's what I'm trying to find. So let's do that. I'm gonna go over here, replace the T2 by what? Replace the T2 by what?
4A.
4A. And then replace the T1 by what?
T2.
Replace the T1 by what?
A. Well, you got the different.
Where do you get the T1 in terms of A?
You're gonna get from second equation, you're gonna.
Yeah, from here. You're gonna arrange this equation and get T1 by itself. It's gonna be in terms of A. You replace it here, and then the T2, you replace 4A in the T2. So what's gonna happen is the equation is gonna have only A, and that's what we're trying to find. All right, so let's do that. So I'm gonna write 1.5 times T1. Now what's T1? You can do it mentally. What's T1? If you move minus T1 on this side, you move 25A to the left. T1 is 245 minus 25A. Come on. Algebra 1. If you want T1, you get the T1 on the other side, becomes plus T1, and then you move the 25A to the left. So you're going to have T1 on the other side, so you're going to have 245 minus 25A. Minus 25A. All right, so that is the 1.5 T1. Now, minus 1.5 T2, and where do you get the T2 from?
From 4A.
4A. All right, so minus 1.5 times 4A. T2 is 4A. And then the whole thing equals to 7.5A. Look what just happened. We have an equation with one variable, A. So we're gonna solve it. We multiply this first. So we're gonna have this equation here. 367 minus 37.5 A minus 37.5A minus 6A, because 1.5 times 4, and then it should be equal to 7.5A. All right, let me just make a separation here. All right, so now you solve that, you're gonna get 367.5. It should be equal to, when you move the minus 6A on the other side, and minus 37.5 on the other side, you're gonna get 51A. And what do you do now? You just have to divide by 51, right? So A is 367.5 divided by 51, and you're gonna get acceleration of 7.2 meters per second squared. All right? Now, we also need alpha. So if we have A, we can get alpha, right? A is 1.5 alpha. So if I have A, I want alpha, I can divide by 1.5. So alpha is equal to A, which is 7.2, divide that by 1.5. And that's gonna give you 4.8 radian per second. So this is 4.8. All right?
Yep.
Radian per second. Square. Radian per second square. That's it.